Hello fellow Viperheads and welcome to Viperhead TV. My name is Indica Pine and today I'm finally going to get to the lights video. So I had one follower ask me about LEDs and I do want to let you know that I am going to be making a video on that. I'm making a video solely on LEDs because I just found so much amazing information on it. So a lot of information that could possibly be very, very helpful to a lot of my viewers. So I want to provide as much information as I possibly can. First off, I want to go over the fundamentals of the lights. You are going to need to know a little bit of vocabulary. My personal opinion, when you're just starting out with lights and the science behind lights and such, I feel that there's three terms that are very, very important. Photosynthesis, which is the process in which a plant uses light to produce sugars for energy. Lumens, the measurement of light density emitted. And lux, the measurement of actual light hitting the surface, i.e. that light hitting my face. The light actually hitting my face is a lux, whereas the light being light being emitted from that bulb is a lumen, if that makes sense. 1 lumen is to 10 lux. One way the High Times magazine described a lumen was a half a foot candle lit is equal to 1 lumen. So if you have 10 of those, that is a lux. Or something like that. I think I might be getting that wrong. I can't remember what they said. But the amount of lumens decrease over a distance, so that means that the amount of time it takes that light right there to get to my face, that light will decrease by the time it gets to my face, and this is because of the inverse square law. The inverse square law is, and I quote, "The intensity of light from a point source, energy per unit of area perpendicular to the source, is inversely proportional to the square of the distance from the source of an object twice as far away, receives only a quarter of the energy in the same time period." So what this means is if 1 lumen is 1 lumen is equal to 1 square foot of light from the ceiling, then at 2 feet above the ceiling, that lumen is now only a quarter of a lumen because the intensity diminishes over a greater distance and greater surface areas. So in order to accommodate for that, you need to supplement more lighting to reduce the light losing strength and ensure there is an even light over this larger surface. If you have only 1 light bulb shining down on a larger surface, it's not going to illuminate that small little surface as well if you were to put 2 different lights, or if you have, for example, a long room with 2 lights up top, then you're going to see a cross between those lights where one part gets more light and a couple parts are a little bit shaded, and in order to enhance the crop and enhance the yield in your grow, you're going to want to ensure that you don't have any of those crosses. You're going to want to make sure that everything is completely even throughout your whole grow room. Another thing that's really important to remember, and I think a lot of people kind of forget, is that a light bulb shines 360 degrees around. So that means that if a light bulb is 140,000 lumens, this right here is our light bulb. That means in all directions, right here and right here, it is shining light. So if you factor in distance and the inverse square law, you're only getting about 2,000 lumens, per whatever you're shining it on. If you're using my face is only getting about 2,000 lumens from the 140,000 lumen bulb you have, hooked up in your wall. A good thing to kind of help with that is to invest in a really good reflector. And I'm not necessarily saying, get a really, really expensive one, but, look for one that does its job very well, reflects very, very well. I had that follower ask me a question regarding, she was wondering if she took a plastic sheet if she could take this like plastic sheet, kind of like a magnified plastic sheet, and put it on, I think on her reflector, if I'm understanding your question right, putting it on her reflector over her light to intensify the amount of light to produce a better yield or whatever. Well, I did a little bit of research and I couldn't really find very much information regarding that specifically, but in my honest opinion, I don't really think that would be a very good idea. You're just intensifying the heat and the brightness of the light. I don't really see any, I can't think of like a scientific reason as to how that would really work, because you're not doubling the amount of lumens, you're not, doubling the amount of ultraviolet lights or anything, you're just intensifying the light, if that makes sense. It would probably create more light burn than anything, I think. Just the way, I don't know, it's just the way my brain's working, though. What High Times recommends, though, is to hang your lights vertically, so hang them up and down like this, and that will help that'll help enlarge the amount of lumens that are being emitted from your bulb. You hang them down, like it might not, this room right here is very vertical, so you don't have very much space in here. You would have probably just enough room to put plants along the side and then just have the lights down the middle, which would make it a little bit hard to walk through unless you're like crouching down, bending over and such. So, if you have a more square room, it'd probably be a little bit easier to do that, because then you'd be able to kind of line the plants up around the room, put the lights right in the middle, and the plants would probably want to grow into the light, which you could then, stake back, and that would give you enough space to kind of walk around the perimeter of the room, in between the lights and the plants. So I hope that helps a little bit. Going back to photosynthesis, light hits the leaf. The leaf uses various pigments like chlorophyll A and chlorophyll B to absorb said light and create photons. Photons combine with water to then create energy to convert the carbon dioxide molecules into sugars and carbs and other organic compounds. Plants use different sized wavelengths within the spectrum of light or spectrum of color to produce this energy to, create fuel. So if you were to supply plants with the specific wavelengths or color of light that they need, it would assure a much healthier crop. Another thing that people utilize a lot is the PAR, or the photosynthetically active radiation values. They help identify the amount of light that is usable by plants. It's a more precise measurement of light. It focuses on the specific spectral wavelengths crucial to the cultivation of cannabis. I do believe that it is used for various other plants as well, but in this case we're talking about cannabis, so but I hope that this information helps. I do go into a little bit more detail on my blog, not very much. If I don't give you the exact information that you were looking for, please feel free to let me know, and I will do as much research as I possibly can until I can answer any of your questions. I'm even willing to send personal messages if there's something very, very precise and in particular that you need answered to your very, very specific and precise case. So thank you so much for watching Viperhead TV, and until next time.